Welcome back to the training series of TAE certification. In today's session, we will explore the domain of TAS development and how it aligns with the software development lifecycle. So without any further delay, let's proceed. In this slide, we will discuss the development of a TAS and its comparison to journal software development projects. Let's break down the key points. The first one is development similarity to other software projects. Okay, so developing a test automation solution is very similar to developing any other software project. So this means that the process of creating a test automation solution involves typical software development procedures and practices. And these procedures may include requirements gathering, design, coding, testing, and deployment, among others. Then we have peer reviews. So peer reviews involve having team members review the code and design of the TAS to identify issues, ensure quality, and also provide feedback. Then we have specific considerations for TAS. So while test automation solution development shares similarities with journal software development, it also has its own specific considerations. So two of the key considerations are mentioned over here. And the first one is compatibility with the SUT system under test. Right, so this means that the test automation solution must be compatible with the system it is intended to test. So this means it should be able to interact with the SUT effectively and in a way that accurately tests its functionality. If we take an example, let's imagine you are automating the testing of a web application. So now in this case, the test automation solution must interact with the web application's user interface and verify the application's responses. In this case, the interaction can be, for example, clicking buttons, filling out forms, etc. Okay, now the second consideration is synchronization with SUT. This means that the TAS must synchronize or coordinate its actions with the SUT. And why this is important? Because this ensures that the tests are performed in the right sequence and the results are reliable. If we take an example of a mobile application, so in a test automation solution for a mobile app, you might need to synchronize actions like waiting for elements to load or ensuring that actions occur in the correct sequence. Timing is crucial in test automation. So your TAS must be designed to handle delays, timeouts, and synchronization with the SUT. Next, we have integration with test automation architecture, TAA. So we have discussed the test automation architecture in so much detail in section 3.2. So the above considerations should be taken into account both in the design of the TAA and in the development of the TAS. Lastly, we have impact on the SUT. So the SUT can be impacted by the test strategy. So in other words, the way testing is conducted, including the use of the test automation solution, can have implications for the SUT. The SUT may need to provide specific test interfaces to accommodate the TAS. So let's say that in some cases, it may be necessary to set up custom testing environments within the SUT. So these environments could be clones of the production environment with specific configurations for testing purposes. Now these environments should be easily provisioned and managed to accommodate the TAS needs. Okay. In this slide, we'll go through SDLC for TAS. Test automation solution development follows a structured approach, much like the SDLC used in journal software development. This structured approach ensures that TAS projects are well-defined, efficient, and reliable in their role of automating testing processes. This diagram shows the basic SDLC for TAS. Let's go through all the phases one by one. So the first phase is the analysis phase. The set of requirements for a TAS needs to be analyzed and collected. Okay, so this means that this analysis phase involves gathering and analyzing the specific requirements for the TAS. So it is the initial step in understanding what the TAS should achieve. Second, we have design phase. So the requirements guide the design of the TAS as defined by its TAA. So in this phase, the gathered requirements are used to design the architecture and plan the structure of the TAS. And it involves defining how the test automation solution will function and interact with the SUT. Next, we have development phase. The design is turned into software by software engineering approaches. So once the design is finalized, the test automation solution development begins. So this phase involves writing code or script to create the actual software. Then we have testing phase. And like any other software, a TAS needs to be tested as well. So after development, the TAS undergoes testing to ensure its functionality and reliability. This phase often starts with basic capability tests to verify core functionality and then moves on to the actual testing of the SUT, where the TAS interacts with the SUT to execute test scenarios and validate its behavior. So this interplay between the TAS and SUT is a fundamental part of automation testing, where the TAS acts as a controlled user to assess the SUT's functionality and performance. Then we have deployment phase. After successful testing, the TAS is deployed to the target testing environment, which is production-like. So once the TAS is tested and ready, it is deployed for use in the targeted testing environment. It's very important to ensure that the TAS functions correctly in an environment that closely resembles the production environment before deploying it to the final destination. And then we have evolution phase, and the first point in evolution phase is often a TAS evolution is needed to add more test capability, change tests, or to update the TAS to match the changing SUT. Okay, so this means that as testing needs evolve or the SUT undergoes changes, the TAS may require updates or improvements. This phase invokes making modifications to the TAS to ensure that it remains effective and aligned with the SUT. The second point we have is that the TAS evolution requires a new round of TAS development according to the SDLC. So when significant changes or additions are required during the evolution phase, a new round of TAS development follows the same SDLC process. Now, there is a note as well that the SDLC does not show the backup, archiving, and tear down of a TAS. As we can see in the diagram, it's not mentioned. As with the TAS development, these procedures should follow established methods in an organization. Okay, so what does that mean is that the reason these processes like backup, archiving, and tear down, they are not typically part of the SDLC diagram or framework. And the reason is that they are often considered operational or maintenance tasks that come after the development and deployment phases. So the SDLC primarily focuses on the stages related to the creation and enhancement of the TAS itself, from analysis and design to development, testing, and deployment. And organizations usually have their own policies, procedures, and tools for managing backup, archiving, and tear down processes, which can vary depending on their own specific needs or maybe compliance requirements and even the industry standards. So these processes are important for ensuring data integrity, resource management, and efficient operation of the TAS and the testing environment. With this, we have reached the end of today's session. Thank you for joining me today. Until next time, happy testing.